You've all seen it at some point in time in middle school and in high school, in your previous travel. Some of you who are in construction will certainly have seen it when you're building a staircase, when you're building a roof, building an incline of any sort. You have to use Pythagorean theorem. And so Pythagorean theorem comes to us from Pythagoras, who's a Greek mathematician. And he theorized this, that given any right triangle, as shown in the diagram, we have a right triangle, and a right triangle is defined as any triangle that has a right angle in it. A right angle is a 90-degree angle as one of the internal angles of the triangle. Given any right triangle, what he theorized is if I square side A, one of the shorter sides, and I square side B, another one of the shorter sides, and I add the squares together of a squared plus b squared, that will calculate to be equal to the length of side C squared. So here's the famous equation. You all may remember a squared plus b squared is equal to c squared. And that is a reflection of the diagram that's shown in this particular slide. Now, if we switch things around, remember, like Ohm's law or like Watt's law, if you have two quantities, you can always calculate the third. Got that? If you have two, you can always calculate a third quantity. So we're not always looking for the hypotenuse. If we designate A as being one of the short sides, B as one of the short sides, and let's say we use C as the hypotenuse, I can rewrite the equation here in this first line. I can rewrite it this way, where c squared is equal to the sum of a squared plus b squared. But more specifically, I don't want the square quantity, I just want c. If I'm solving for just the side of the hypotenuse, then it is equal to the square root of a squared plus b squared, as shown here. If I'm looking for one of the shorter sides, the equation, the primary equation, can be rewritten as a squared is equal to c squared minus b squared. But again, I'm not interested in a squared. I just want a. I just want the side. So how do I calculate this? This would be calculated as a is equal to the square root of c squared minus b squared. And then finally, I can do the same for the remaining side, b. And again, I'm not interested in b squared, I'm interested in b. And to solve for b, b is equal to the square root of c squared minus a squared. So all of these formulas should go into your journal. And how we're going to apply these formulas is going to be as follows. So let's take a look at the practice of Pythagorean theorem. So pull out your calculators and take a look at this particular triangle. First of all, can we use Pythagorean theorem on this triangle, yes or no? It's a yes. Why is it a yes? Because there is identified in the corner a little box. This little square indicates that this is a right angle, meaning this is a 90-degree angle. And as long as I have this little square drawn in a corner, it tells us we have a right triangle. Now, as long as we have a right triangle, we can apply Pythagorean theorem. So we identify this. It says, as the hypotenuse and one side are given, the hypotenuse we discussed is the long side of a triangle. It is also the side that is opposite of the right angle. This will always be called the hypotenuse. The other two sides will have names. We'll talk about that in another slide. But for the time being, the long side is the long side is the hypotenuse. It is opposite the right angle, and it happens to be given as 25 yards. You're also given one side as being 15 yards. You are asked to find the remaining side, which is designated by the points on the corner, N through L. So I'm looking for the length of NL equals to some number. And the way we do this is if you take a look at I can use any one of these two equations, it doesn't matter. The length of the missing side is going to be equal to the square root of the hypotenuse squared minus the one side that is given squared. What's 25 squared? So you punch that into your calculator, you punch in 25, so turn it on, 25, hit your square button, boom. You should all get, if you hit engineering, you should all see 625 on your calculators. Clear. 15 squared equals, then hit engineering. You should all be able to see 225. So mathematically, you have a 625 minus a 225. You could do that in your head. You have 400, but it's under the square root symbol. So what you need to do is you need to do the square root of 400. So you need to find a new key on your calculator we haven't used too much, and that is the square root. So in your calculator, it happens to be its own key. So you hit square root, and you enter 400, and you hit equals. And what does your calculator show you? Should show you 20 if you hit engineering. Yes? Okay. Your keystroke sequence, if you were to do this on the calculator completely, will be as follows. And do this keystroke sequence together with me. Okay? So as you do the keystroke sequence together with me, take a look at this. You hit the square root key, and you have to hit open parentheses. Then you hit square, open parentheses 25. Then you hit the square key. Then what's after that? Subtract. Then you hit 15, and then you hit the x squared key. Then you have to close parentheses. Then you hit equals. And when you do that, you hit engineering, in one fell swoop, one single line of keystrokes, you will have 20. The same result as we did 2 lines above on the slide, but yeah, this is with one single keystroke sequence. So you got to learn how to use this calculator effectively. Don't forget the parentheses. Some of you who were practicing product over sum over the past week for current dividers and parallel circuits, when you're doing product over sum, you have to use parentheses. If you don't use parentheses, your calculator will give you something that is incorrect. Not because the calculator is wrong, but because it does what we tell it to do, and we need parentheses. So how do we know 20 is correct? Just because your calculator spits out a number doesn't mean you write it down automatically. You should double check it. So how do you double check it? Well, you put it back into the original a squared plus b squared equals c squared equation. And when you do, you have 20 squared plus 15 squared. Does that actually equal to 25 squared? Well, you work out the math. 20 squared is 400. 15 squared is 225. When you add the two together, does it equal 625, which is 25 squared? The answer is yes. So are you happy that you have double checked the value that your calculator spit out for the unknown side? So in a rush to do things, I've seen a lot of students click, 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 click on their calculator, boom, it gets the number, they write it down, they move on. They don't double check. And you know from the previous test and other homeworks that you have done, my notes to you, some of you are going really fast and making simple calculator errors. Somebody was calculating RT in parallel. We know that RT in parallel always has to be less than the lowest ohmic branch. Well, somebody does the calculation for RT, they hit reciprocal, and then they write down the reciprocal number. So no, you have to reciprocate one more time at the very end. Somebody didn't do that, and therefore their answer was wrong. Calculator didn't make a mistake, they were just simply rushing. So the same thing is true with Pythagorean theorem. Don't rush. Double check your answers. It's very easy to do. Next slide. Guess what? You get to practice. So everybody work on the first one right now. I'm looking for side BC, the very first set of triangles at the top. I'm looking for side B to C. What is given? What is not given? Work on that. And then I'm going to ask for you all to show me your calculators. So I need for your Wonderful smiling faces. Cameras on, calculators ready. Oh, Anna, a little closer to the camera. Oh, that looks good. Okay. And let me pull this out so we can see more. And yeah, Luis, that looks really good. Kirsten, hold it a little with an angle. Yeah, okay. As long as light hits your screen, then I'm able to see the number. That looks great. Tawan, that looks great. Harpreet looks great. Ryan looks great. Frank, that looks fine. Sideways, I can see it. Tony looks really good. Jess looks really good. Okay. Can we have some additional classmates that need to show me their work? Okay, let me go ahead and widen this. And Greg, I don't think, you want to recalculate that, Greg? I don't think it ends up with a whole lot of decimals. Carlos, do you have a calculation for this, please?
I didn't get it right because I think I didn't understand the keystrokes. Can I look at that one more time really quick?
Yes, okay. So let's take a look at the facts here. Yeah, a number of you are showing me really, Chisamaga looks wonderful. Andrew, no, we're gonna have to show you how to do that. So I'll show a couple people how to do the keystrokes for this guy. So on this particular triangle, let's see what it is that we have. We have, and this is not necessarily drawn to scale, and we want B to C. Okay. Well, let's see if I can do it this way. Let's go to here, and let's go to stop share, and let's go to speaker screen. So as you're looking at this, are you looking at this? It's interesting how this computer shows this. All right. So right angle, this is opposite the right angle. This must be the hypotenuse. This is the longest side. So if we know the longest side, remember your equation was a squared plus b squared equals c squared. We're looking for one of the sides. So a squared is equal to c squared minus b squared. Or simply a is equal to square root of c squared minus b squared. In this particular case, what we're looking for, the value of b to c, is going to be equal to the longest side squared, which will be 15 squared, minus this other side that is given, which will be 12 squared. And the way you do the keystroke sequence for this, for those of you who showed me your calculators and I said that it wasn't quite right, you do this. You hit the square root key first. And you have to make sure you hit your open parentheses key. You cannot forget the open parentheses. Then you key in 15. Then you key in your x squared button. You key in your subtract button. You key in 12. And then you hit your x squared button here. You have to close parentheses. If you rush and forget to close parentheses, all is lost. You have to redo this. Then you hit equal. So if you use this keystroke sequence exactly as I have written, what it is that you will be able to do is generate a number that looks like your classmates. So would you do that, please? Those of you who showed me your calculations and I said was in error, does it work for you this time? Andrew?
Sorry, I couldn't get that. I got 9, but let me get rid of the background so you can see it.
Oh, 9 is fine. Yeah, 9 is correct. Andrew, were you able to get the answer?
Yeah, I had my calculator up. I got 9. Yep.
Okay, good, good, good. All right. So the keystroke sequence is not a hard keystroke sequence. You just have to remember you've got parentheses right after the square root and right before the equal sign. So get to do another one. Okay. Next one. We're not going to do all of these, but let's go ahead and give you. Let's say, look at this. Look at the middle row, and I'm looking for side m to n. So in the middle row, the very first one, you're shown a triangle that looks like this. And you're given L and N, and that side is 16. And then you're given this side is M, and this side is given as 8. And you're asked to look for the long side. Well, your shorter sides are always going to be AB. One of them is going to be A, one of them is going to be B. The long side is always going to be the hypotenuse. So don't we start off with, isn't C squared equal to A squared plus B squared? Yes? So C, all by itself, the hypotenuse is going to be C, is the square root of A squared plus B squared. So C is going to be equal to, doesn't matter which is which, let's say 8 squared plus 16 squared. Does everybody have an understanding how we develop, pick which equation to use, and finally arrive at how the numbers go underneath the square root symbol? I know I'm writing pretty fast and I'm speaking pretty fast, but how do we know it's going to be this combination? We've always said it doesn't matter which one of the short sides is A or B, but the long side will always be C. And if the long side is C, we're asked to find C. C squared equals the sum of A squared plus B squared. I don't care about the square of C, I just want C. So in order for me to find C, I have to get rid of that square. The way to get rid of a square on one side of the equation is to move it over to the other side as a square root. Mathematically, that's the justification for doing the second line. Now we just have to plug in the values. One of the short sides was an 8, square it. The other one of the short sides was 16, square it. How does this go into your calculator? Into your calculator, can you look at your previous step? Can you write out the keystroke sequence? Can you call out the keystroke sequence? Jess, can you call out the keystroke sequence for us, please? Want to give that a shot?
Sure. So on my calculator, I hit the square root.
Okay, I'm going to do a square root. Okay, then?
And that actually automatically adds the open parenthesis.
Oh, your calculator is so nice. So it automatically adds the parentheses. Then, but for the rest of us, we'll put it in. Then what do we do?
Hit the number 8.
Hit the number 8. Then what do we do?
I have an X squared button that I hit.
Okay, then I will hit an X squared button. Then what do we do?
Add the addition button.
The addition button. Cool.
And then the numbers 1, 6 for 16.
1, 6 for 16. Good.
And then the square button again.
The square button again.
Yeah.
So X squared. All right, then.
The close parentheses.
The close parentheses. Okay, then.
Enter.
Then enter, or equals in our case, yes. And the magic answer works out to be what value? Tolan, what's the value?
17.88.
15.88?
17.88.
Oh, okay, I missed, okay, so 17.88. How many people agree with 17.88? Give me a thumbs up on your screen. Uh-oh. Uh-oh. Anna, what do you calculate?
I got 17.89.
Oh, 17.89. How many people agree with 17.89? Give me a thumbs up. All right, 17.89. And so you've got to be careful. You can't be off by that hundredth of a digit on a simple calculation like this if it's a rounding error. So let me just double check that. Square root, open parentheses, 8 squared plus 16 squared. Oops, messed up. 16 x squared, and then close parentheses and engineering. And yes, that third 8 makes this a 17.89. So definitely watch that. You don't want to be making that kind of a mistake on the forthcoming test, okay? Because our standard is to the 100th. All right. So is all this pretty basic so far? No big deal, yes? Any questions so far? Okay, things get interesting now because this is fine in a middle school geometry class or a high school geometry class, Pythagorean theorem. This is great. This has some bearing on what we're doing in electronics, but we need to take this one step further. To have it applicable for electronics, I need to know how to calculate the angles inside a right triangle. And the relationship of the angles with the sides in a right triangle is... Hello? Yeah, somebody have a question? Okay, just remember to mute your microphones unless you're called on. Right, so what's helpful to us in electronics is knowing how to calculate the angles inside these triangles, because in the next 2 weeks, as we play with capacitors and as we play with inductors, we need to know the angle relationships. And that's really easy also.